Here, neat sketch explain the working of a nuclear reactor. A nuclear reactor is a device in which the nuclear fission reaction takes place in a self-sustained and controlled manner. Fissile material or fuel. The fissile material or nuclear fuel generally used is 92U-235, but this exists only in a small amount, that is 0.7% in natural uranium. Natural uranium is enriched with more number of 92U-235, that is 2 to 4%, and this low enriched uranium is used as fuel in some reactors. Other than U-235, the fissile isotopes U-233 and Pu-239 are also called as fuel in some of the reactors. In the pressurized heavy water reactors built in our country, natural uranium oxide is used as fuel. Tiny pellets of uranium oxide are packed in thin tubes of zirconium alloy and sealed to form a fuel rod. 19 such rods are tied together to form a fuel bundle. The reactor vessel, which goes by the name calandria, has about 300 tubes passing through it. The fuel bundles are placed in these tubes. The part of the reactor vessel which contains the fuel rod is known as reactor core. In the pressurized light water reactors, low enriched uranium is used. In the fast breeder test reactor at Kalpakkam, a mixture of the carbides of uranium and plutonium is used as fuel. The fuel of the prototype fast breeder reactor that is being built at Kalpakkam is a mixture of oxides of plutonium and uranium. In the fast breeder reactors, the fuel pellets are packed in special stainless steel tubes to withstand the high temperature. Kamini Kalpakkam mini reactor is the only operating reactor in the world which uses 92U-233 as fuel. In this reactor, the fuel is an alloy of uranium and aluminium and it is in the form of plates. Moderator. The function of a moderator is to slow down the fast neutrons produced in the fission process having an energy of about 2 MeV to thermal neutrons with an average energy of about 0.025 electron volt, which are in thermal equilibrium with the moderator. Ordinary water and heavy water are the commonly used moderators. A good moderator slows down neutrons by elastic collisions and it does not remove them by absorption. The moderator is present in the space between the fuel rods in a channel. Graphite is also used as a moderator in some countries. In fast breeder reactors, the fission chain reaction is sustained by fast neutrons and hence no moderator is required. Neutron source. A source of neutron is required to initiate the fission chain reaction for the first time. A mixture of Beryllium with plutonium or radium or polonium is commonly used as a source of neutron. Control rods. The control rods are used to control the chain reaction. They are very good absorbers of neutrons. The commonly used control rods are made up of elements like boron or cadmium. The control rods are inserted into the core and they pass through the space in between the fuel tubes and through the moderator. The cooling system. The cooling system removes the heat generated in the reactor core. Ordinary water, heavy water and liquid sodium are the commonly used coolants. A good coolant must possess large specific heat capacity and high boiling point. The coolant passes through the tubes containing the fuel bundle and carries the heat from the fuel rods to the steam generator through heat exchanger. The steam runs the turbines to produce electricity in power reactors. The coolant and the moderator are in the same in the PHWR and PWR. In fast breeder reactors, liquid sodium is used as the coolant. A high temperature is produced in the reactor core of the fast breeder reactors. Being a metal substance, liquid sodium is a very good conductor of heat and it remains in the liquid state for a very high temperature as its boiling point is about 100 C. Neutron reflectors. Neutron reflectors prevent the leakage of neutrons to a large extent by reflecting them back. In a pressurized heavy water reactors, the moderator itself acts as the reflector. In the fast breeder reactors, the reactor core is surrounded by depleted uranium, that is, uranium which contains less than 0.7% of 92U235 or thorium 90 Th232. It acts as a neutron reflector. Neutrons escaping from the reactor core convert these materials into Pu239 or U233 respectively. Shielding. As a protection against the harmful radiations, the reactor is surrounded by a concrete wall of thickness about 2 to 2.5 meter.
Please subscribe our channel for more videos and educational contents.